Okay, we are going to go back to our baseball salaries example that we looked in chapter 2, but now we're going to answer a couple of these questions using visualization. So the first one, how does the distribution of salaries vary by position? Who has the highest, lowest, median? Does the same position have the highest, lowest 75th percentile? How does the distribution of salaries compare between playoff and non-playoff teams? And we're going to go Q2. We're going to break it down even further. We're going to compare it between the World Series, the playoff teams, excluding the World Series, and the non-playoff teams. And as my note here, we're going to have to create a new field of data for that. We'll do this in both Tableau and Excel. What's going to be really cool about this one is, if you remember in chapter 2, we did this problem. We had a histogram and a box plot, and the box and whisker plot really wasn't worth much in that context. This is where that box and whisker plot's really going to come into play, because we can quickly look at a lot of data sets all at the same time and see that statistical data, see the mean, see the median, see the first and third quartile and all that. So let's get right started with it. So we're going to go over here to data, and I'm going to pre-highlight the data because we're going to want position and salary, because that's how we're going to break it down. And so I'm going to highlight the positions, I'm going to hit control, and then I'm going to highlight all the salaries, and I am grabbing the names in there, it's not going to matter. And then we're just going to go insert to our charts. We're going to come here to our box and whisker, and there it is. And so what I'm going to do is I'm going to move that chart. Now I'm going to move it to our answer sheet. Typically what I do when I'm making visualizations to show, I just move them to a new chart. And in fact, let's just do that. And why do I do that? It kind of formats it to fill the whole thing. It's easy to copy and paste. It's easy to see what's going on. Now, a couple things that we need to do is we always need titles and chart. So 2018 MLB salary distribution by position. Now I do want to get those axis titles in there because we really always need those, because we have to know what we're dealing with. It's just a good habit to get into, because they really always should be labeled clearly. Don't really need units here because it's obvious that this is in dollars, US dollars, and we've got our positions here. Okay, so we were quickly able to throw that together. Just a quick review. What is the box and whisker plot? The box here, the first bottom of the box is the first quartile, the 25th percentile. Top is the third quartile, so 75th percentile. The line is the median. The X is the mean. I'm not sure if I just screwed myself up there. Just making sure, because I had to pause it and go take care of something. X is the median, is the mean. It's the average. The line is the median. There's just as many points as above it and below it. I'm sorry if I screwed that up. And so these whiskers come out 1.5 of the IQR, the interquartile range. And so in Excel, any dots that are above so what's the interquartile range? It's the distance between Q1 and Q3. So they extend up. And then these points are anything outside of that. This is where box and whiskers are great, because look, we've got outfielder, pitcher, first base, second, third, catcher, shortstop, designated hitter. We can quickly look at all these populations, and we can see where their averages are and compare to each other, where their means are. Averages and mean, where their medians are compared to each other, where we have data points that are outside. We can see the maxes and mins. So this is a great plot to look at a bunch of different data all at the same time and see these statistical characteristics. So the answer to the question, the highest, who has the highest median salary. So we look through here, the median is that line, and that's by far the designated hitters. And they also have the highest 75 percentile salary. So right here, this line, that means that 75% of all that data is below that line. And so the first baseman would be next with the highest median and the highest 75th percentile. So on the low end, if we go look, just by eyeballing it, it's probably the shortstop, maybe a little bit less than the pitcher. And then if we look at the lowest 75th percentile, that would be the catcher. And so just in general, you can look at it. In general, pitchers have lower salaries because you can see here's the 75% mark with everything else. But there's a lot of stuff outside of that range. So once again, quick way to look at the statistical data using those box charts. And so now what we want to do is we want to look at how the distribution looks between playoff teams and non-playoff teams. So what we're going to do is, instead of doing this by position, we'll do it by playoff team. So same thing, we're going to pre-highlight the data, and I'll get that yes, no, control, pick up my salary, all the way up, insert, go Box and Whisker, and let's just move that to its own sheet. And really we should be renaming these as we go because we want to make sure that everything is neat and we can find it. Sometimes when I'm teaching, I have a bad habit of not doing that, so we got to remember to do that. And so now, same thing, we'll take the title out of this one, but we will put our axis titles in. And so sometimes I'll do that too. You just try to get the little highlighter in there. Click on too much salary. And this was 2017 playoff team. And so once again, we've got two sets of data. We're able to quickly look at things. And so we can see that both these distributions are right skewed, which means that they have a long tail to the right. I know that we're dealing with up and down, but of course I just took my hand and made a rotating motion that you're not going to see. But if this was the y-axis and this was the positive x-axis, so it's kind of like you rotate that when you look at the box plots to do things, this tail would be onto the right, so there'd be a huge right tail, which means that it's right skewed, even though all the data's on the left. That always screwed me up the most in statistics when I took it as an undergrad many, many years ago, but it's always where the tail is telling us where it's skewed. So they are both right skewed. They have similar values. Their minimums and their maximums aren't too different. One big difference that we can see is the 75th percentile or third quartile is definitely much higher than the non-playoffs, and the median is higher for the playoff teams than the non-playoff teams. And actually the average or the mean is a little bit higher too. Okay, so what do we do now? We want to know about the breakdown of World Series team, playoff teams, non-playoff teams. So what we have to do is we're going to have to go and we're going to put in another column. And so I'm just going to go right next to salary. I'm going to go insert. And so what we're going to do is we'll just call this column WS for World Series, playoff, NP, non-playoff. And I'm going to write a nested if statement to basically categorize my data. And so we're going to go if, and we're going to run our logical test. So let's do, so if I2, so if that equals yes, and I'm going to put the quotes down because I'm dealing with a text string now. If I don't have the quotes in there, Excel is going to try to find a function or a range that was named yes. It's not going to find it. It will give us a name error. When you put the quotes in, it alerts Excel to know that it's dealing with a text string. So if I2 says yes, then that is a World Series team. So we will type World Series. Now, same thing. This is going to be a text string, so we're going to need the quotation marks. If it is not a World Series team, so if that word is no, what do we want it to do? Well, we want it to run another logical test. And so we're going to say if. So if it comes out no, it's going to run the next one. So if, let's see, H2 equals yes. So if this column, if this thing says yes here, well then it is a playoff team. And so we will have it return and say playoff. Now, if it says, if it's not yes here, which would be no, it would just be a non-playoff team. And that's going to take two parentheses to close because I have to close off this nested if function and this big one here. And also got to remember our quotations. So it runs the first logical test. If it's true, it returns this. If it is false, it runs the next if statement. I'm just going to double click here to have it drag out. And so now we have set up a new column that we're going to be able to do a new box and whisker plot on. And that's the whole reason I put it right here, is now I'm just going to grab them both at the same time. Won't have to hold control. Just go down, insert, and box and whisker. Have that pop up. We'll move that move chart, put it in a new sheet, rename that Q3. And once again, let's do all the same stuff that we did before. We don't really need a chart title on this one. It's pretty self-explanatory. Just having problems deleting it. It doesn't want to let me delete it. It just wants to live. Okay. So we'll take that away. We are going to add axis titles. We'll call this playoff status. And then we'll call this set. And so once again, we can quickly look at the stuff and we can go, okay, well, the difference between a non-playoff team and the playoff teams and the World Series teams, if we look at things, there's definitely a difference in salary between those. And actually, it looks like World Series and playoffs, pretty similar with mean, median, and our first and third quartile. Non-playoffs, a little bit lower and all that. There are some data points outside of that. But there we go. So once again, box and whisker plots. Not very good with one set of data, but you can see a lot of cool things from different data sets when you look at them together. So this is how to do it in Excel. Part 2 of the problem, we're going to go through these visualizations in Tableau.